Hi everyone, myself and Arun Kumar from SNS College of Technology in the Department of ECE. In this video, I am going to share about half adder and full adder techniques in combination circuits. So these are all the slides we are going to see in this video. Introduction, we are using here half adder and full adder. Half adder is a two input variables A and B, and full adder is a three input variable. So common term which is used for both half adder and full adder is sum and carry, because here we are using XOR and AND gate. So XOR and AND gate will produce an output based on sum and carry. So both will be comes under half adder and full adder. So the full adder techniques will be more added than half adder, because it is used for many number of applications like ripple carry address, carry lookout address. So these are all the address technique which is used for the processor, which will be giving the more number of information based on the input signals. Binary additions. So while going to half adder and full adder, we need to know the addition of binary numbers, because it's a principle which is to be followed in both half adder and full adder techniques. So here the only one thing is 1 plus 0 is 1 and 0 plus 1 is 1, 0 plus 0 is 0. So the thing is 1 plus 1. So here the value will be comes under 0 is sum and 1 will be carry for carry. So the half adder and full adder will be formed based on the truth table and K-map techniques. So the XOR and AND gate will be combined, formed as a half adder. So here the A and B will be given as a input, and sum and carry will be comes under for the output signals. So the input is 0 0 0 1 1 0 1 1, because it's a two input variable, so we can make it as four combinations based on the 2 power n. So 2 power 2 equal to 4. Only 4 combinations will be available to given input, and the corresponding output can be generated based on the gates. So for XOR gate, it can be generated 0 plus 1, 1 and 1 plus 0. The output will be 1. And for AND gate, it is a multiplication. So 1 and 1 will be 1. So like this, the table will be formed, and the corresponding values will be noted in the K-map table, Karnaugh map table. So it can be generated based on the 0 1 0 1. So for example, for sum, we can have a 0 1 equal to 1. So here 0 1. So 0 1 equal to 1, and 1 0 equal to 1, 1 into 0 1. So like this we can place the numbers of the corresponding inputs. So after completion of placing the numbers, we can able to write the expressions. So here a bar, next one is a. So 0 is known that bar, so I can make it as a bar, and next one is a, and like that b bar and b. So the corresponding row and column we need to write in the expressions. For example, here the one means we need to write a bar into b bar b. So a bar, so here the one the above value is b, so a into b. So like this, all the value will be comes under the K-map table. Full adder. So for adding two half adder with the help of OR gate, it is known as full adder. So OR gate is known as an additional addition, so that we can use addition circuit for this two half adder. So here we are giving a three input like previous half adder. So in a half adder we can give only two inputs, but here additionally Cin, so that we can give three input variables. 2 power 3 equal to 8. So 8 variables, 8 inputs can be come. So like this previous model, the output also generated, because let me check the one output. 0 plus 1 1, and 1 plus 0 means 1. So 1 is sum. Next one is 1 plus 1 0, and carry also 1, so that it will be placed as a carry 1 C out. And next one is 0 plus 1 1, so it will be placed in sum. So like this, all the one value will be marked here, and we can mapping also done based on the adjacent value. So here the mapping can be done based on the adjacent values, because we need to check the possibility. If it is nearby one means, then we can able to make it as a group one, so that here the possible combination of grouping has been done in this carry model. So here we don't have any adjacent value, so that I won't group anything here. So after grouping, we need to write the expression based on the previous model. Applications. So it can be used for arithmetic logic unit and digital signal processor like Snapdragon, Qualcomm processors. Nowadays we are using the processor for making efficient speed. and memory allocation and embedded system like ARM Cortex processor, ARM holding so laptop and all using this embedded system processor. And for control system, it will be used for digital computation and automation techniques. So assessment, a digital watch needs to add a seconds continuously. So the designer use a half adder or full adder. Why? A full array is used because it can add three inputs, 2 bits plus carry also added for this input, and this allows to make a more number of combinations or adding more number of digits. So what to handle to continue the time as a counting. Unlike the half adder which cannot carry because it doesn't have any C additional input C in. So we are using full adder for this digital watch. Thank you.